All right, this one is we're looking at, is this convergent or divergent? So look back through the test, try to pick out things in the series that might help us to determine which test is best. There's no power of n, so it's not a root test. We don't have a factorial, so I don't think ratio tests need to be used. However, this series is very similar to the series 1 over n squared. And we know that this series is convergent by p series because our exponent there of 2 is bigger than 1. So if we show that this series that we're looking at is less than a convergent series, that's always going to be convergent. So is 1 over n squared plus 1 going to be always less than that one? I'm pretty sure it is here. If you try like some of the numbers out here, if we put 1 in for both of these, then we got 1 over 2 here, whereas this one would be 1 over 1, which is 1. If you'd put 2 in, now this side would be 1/5, where this side would be 1 over 2 squared is 4. 1/5 is smaller than 1/4. If you keep going, the same is always true. So this series over here would then also be convergent. I'm just going to say convergent here. Convergent by comparison. All right, let's take a look at another one here. Here we have a series, and you can see that there is a -1 in there. So let's try what we just learned here with our absolute value. What if we were to do the absolute value of this one and test for absolute convergence? So if we do that, that should be this. That should be similar then to this series where we would have the absolute value of that -1 to the end is always going to be 1 there. So then this should just be similar to this series. Well, let's see what we know about this series. Another way to write this one out would be that in our numerator, we could write this as 2 to the third to the n, because power to a power you multiply. So this could also be written then as 2 to the 3n like we had just in this step before. Well, I can do 2 to the third power. 2 to the third power is going to be 8. So we could write this as 8 to the n over 7 to the n. And since they're both to the n power, let's write it as just 8/7 to the n. Well, that's a geometric series, and we know that anytime that what's in the parentheses there is bigger than 1, then it's going to be divergent. So what we can say here is that this one is divergent because our value is bigger than 1 when we have a geometric test here. All right, let's have you guys try a couple. So for this one, take a look at it, pause the video, and give it a try. Notice that there's a factorial there. Hopefully that kind of gives you an idea of what to use for this one. All right, hopefully you've had a chance to do this one with that factorial. Ratio test would be a good one to try here. So let's do the limit of our a sub n plus 1 over our series here. Doing that, make sure you only put the plus 1 where there's n's here. So both of those two n's need the n plus 1. Notice that this 2 is outside of that n plus 1 because we'd only be adding 1 to the n. So now let's try to simplify this. First thing we can do here, multiply both numerator and denominator here by the reciprocal of the denominator here. So we'll multiply that. That gives us what we got here. Now let's try to do some simplifying on that. You can do that here by one. If we got something squared, it means we're going to have two of these n plus 1 factorials. So I wrote them as n plus 1 times n factorial, which we know is equivalent over our two n factorials. So those n factorials are going to be gone. I also here uh, multiplied this out since we have 2 times n plus 1. I distributed that, giving us 2n plus 2 factorial. So if we think about that one, we can write that as 2n plus 2 times the term that's next, which would be 2n plus 1, because that's 1 less. If we minus 1 from that, that would just be 2n uh, on down, so that would be 2n factorial. So we can also cancel out now our 2n factorials. That leaves us with just this. I multiplied the numerator and denominator out, giving us this limit. And we know if we multiply by 1 over n squared that this is going to end up going towards the coefficients here of our largest degree, which is 1/4. And 1/4 is less than 1. And so this one, anytime you do ratio tests and it's less than 1, it's convergent by the ratio test. So hopefully you had good luck with doing that one. I want you to try one more here. Test and see if you think this one is convergent or divergent. All right, let's take a look, see what you came up with. We do have one of these alternating things here, so let's take the absolute value because that's either going to be -1 or 1, and absolute value both is 1. So if we take the absolute value, that just makes that a 1. So now we just are left with this series. Notice that those both have powers of n. So that might be a good one to use root test. So hopefully you saw, let's do root test on this one. So let's do the limit as n goes to infinity of the nth root here of that series. Remember, nth root is the same as taking it to the 1 over n power. So if we do that here, that means we'd be multiplying 1 over n to both of those. So the power of n in the numerator is just going to go away. Here on the denominator, it'd be like n squared times 1 over n, canceling out one of those. So we'd be left with 3 to the n. So what is this going to do as we go to infinity now? Well, n's going to go to infinity. 3 to the n's also going to infinity. That's indeterminate. We need to use L'Hopital's here. So derivative of the top is 1. Derivative of the bottom is 3n natural log 3. As we go to infinity now, top's just going to be 1. Bottom is infinity. So that's going to go to 0, which is less than 1. So this one is convergent by the root test. And we can go even further and say that because we took the absolute value here when we did this, that this is absolutely convergent by the root test. So that would be the answer we want for this one.